Hello everyone, let's get started. Week 7, section properties lecture. So today we'll locate the center of area, centroid, and calculate the first moment of area, and then solve the equilibrium equations of a beam under distributed load. So we solved the equilibrium equation last week, right? 2D and 3D, right? And it was very important. But for 2D problem, we didn't think about distributed load, right? And then to solve that, we need to know how to find the centroid and other section property knowledge. Okay, so start with center of area. So center of gravity of plate is the point where the weight is applied to the center of the earth, right? And if the material is homogeneous and thickness is the same, then the centroid center of gravity is the same as center of an area, right? So that's center. And if we have simple shape, then it is wide known. Centroid location is widely known. So this is kind of warm-up quiz. So for this triangle, where is the center of area? Is it 0, 0, or B third B, or H over 3, or C is B over 2 and then H over 2? The question is centroid. Where is the centroid of the triangle? It is too easy, so very quiet. Yep, so I close after 10 seconds. Okay, predominantly B, right? So B is correct. Yeah, B is, so 1/3 B and 1/3 H is the centroid of triangle. And then so half B and half H is centroid of a rectangle, right? So that's that. And then we confirmed from this clicker quiz that finding centroid of a simple shape is very easy. And then tables are already developed, so we can use the table. We don't have to, think about it, right? So triangle or half circle, quarter circle, or even parabolic, you have X bar, Y bar coordinate, and the area equations are here. So it's from the textbook. So, and then if needed, I'll give you this table for exam too. But if we have composite shape, it's most likely for biomedical, civil mechanical, we have all the time composite shapes, right? It's a beam, column, right? And everything is composite. So if we have composite shape, then finding centroid is kind of lengthy procedure if we have very complex shape, right? So this slide is talking about that. So if we have complex shape, composite shape like this, and we basically use divide and conquer. We cut the complex shape, composite shape into simpler shape, like 2 triangles and 1 rectangle, and they use this formula, and then finally finding X bar and Y bar as this sum of, small X bar is X coordinate of the centroid of small decomposed section, like this, right? Times area of the small section, sum them up, divide by the entire area. And the Y bar is similar, but we are using small Y bar. So this Y coordinate of each, centroid of each subsection, right? Okay, so this is very important equation we'll use today, and then we'll use this for the first problem. Okay, and any question about the centroid? Okay, then move on to the first moment of area. So definition is moment of an area about a specific axis. So what was the moment? Force times moment arm, or F, the perpendicular distance, or R cross F. That's what we learned, right? And then we always use force, but force is kind of vector, right? And then moment of area is moment of area. So instead of the force, we are using area, right? And then what is moment arm? Moment arm is the distance between the axis to the centroid of that area. So this distance, right? So the second line, moment of area is area times distance between the axis, reference axis, and the centroid. So to find the first moment of area, we need to be able to find the centroid, right? So I'll show you this example. So there is a square, looks like square, right? And then we just learned the definition of first moment area. What is first moment area about y-axis? So there are 4 choices, and then choose one based on the tip and the definition here. Is it A, or y bar times A, or x bar times A, or x bar times y bar times A? We discuss with your peers and then decide. Okay, I close after 10 seconds. Okay, so C has the most votes, but we have some B's and D's. Okay, so the area, so area times distance between the axis and centroid, right? Area is A, right? So A should be here, and then multiply by distance between the axis, so y-axis, and centroid indicated here. So distance between these x bar, right? So x bar times A, C is correct, right? And then y bar times A is qx, and then A is not correct. Area is area, and then this one is not defined, okay? Okay, so now let's move on to the equations part, very important. So center of area, so centroid equation. So this equation is what I showed you before, right? X bar is sigma x bar times A divided by the entire area, right? And then we just finished the clicker quiz that QY is x bar times A, right? So x bar times A is QY, right? So this one is same as sigma QY over A. So if you see this kind of equation, then now you know QY is x bar A, QX is y bar A, right? So we can write this equation again with this equation, same meaning, and then these are very important questions for solving centroid of the composite shape. And then sometimes we have continuous shape like this, right? Then we cannot use sigma anymore. We must use integral, right? So then we have this equation. So now it is QI is kind of connection between this equation and this equation, right? So x bar is QI over A, and then here, if we have continuous shape like this, then x bar is QI over A, and then QI is now integral x bar element times dA. What is integral dA? Integration of dA is area, right? So it's the same as this entire area and then entire area. And then this one is x bar times area-ish, right? So, and for the y-axis, same thing, qx over a, and then we can use this one, right? So if you already watched the video, then you probably know the distinction between x bar L and then y bar L, but if you didn't, it's integral, so we use kind of infinitesimal approach, and then we are cutting this air into very thin strips like this, right? And then we choose one of the strip, and they use it as representation of each strips, right? And then when we calculate the area of this rectangle, that is dA, right? Area of this strip, right? And then if we calculate the centroid of this strip, that is x bar L and then y bar L, right? So that is conceptual explanation. And then I use this one and to solve the second or third problem, the last problem today. So any questions so far? Okay. So now we are going to objective 3, equal equation under distributed load. So this is real world example. So far we talked about point load and moment. Those are very important. But another simplified load we consider solving equal equation is distributed load. And for this kind of cases, snow load or hydrostatic pressure or this long vehicle or railway, right? We must use distributed load, so that's why it's important in engineering problems. So in that case, we will simplify and then calculate the resultant and then solve the moment equal equation. How can we do that? I'll explain here. So distributed load is used as force per unit distance. So for example, in every 1 foot, how many pounds were applied, right? So that's the distributed load. It's kind of density, right? So it's kind of intensity, right? And then if we know this intensity and then length of application, then we can find the resultant. So the total load of distributed load, right? So this is demo. So if the ground snow load in stores is 30 pound-feet, so it's kind of maximum snow load in ASE code. And the length of the flat roof of the McHugh building is 50 feet. And then what is the total resultant of the snow load? What do you think? So I'll give you three options. Here, and then choose one of them. What do you think the resultant will be? So distributed load is 30 pounds per foot, and then the McHugh building, the length is 50 feet, right? And then where's the resultant of snow load on the roof of McHugh building? It's 30 pound, 80 pound, or 1,500 pound. Okay, I close after 10 seconds. Wow, C has the most vote. Yes, and then C is correct. Why? Resultant is multiplying if this is constant, right? Like this. Right, and then length is 50 feet, right? Then we multiply this to 30 pound per foot times 50, and then feet is canceled each other, and then multiplying this to 1,500, right? So that's why C is correct. And then A is pound unit, right? And here I show you this is pound for foot, right? So it's different unit, and we have 50 foot, so A is not correct. And then B is adding these two, right? But we cannot add these two because they are different units, right? Okay, then where is the centroid of W if it's rectangle? It is halfway, right? So halfway is the centroid location, and then that is the point where the resultant is applied when we set up the moment equilibrium equation. Okay. Any questions? Okay, then now I think it is the last clicker quiz. So now let's calculate the moment from this distributed load about this point A. Okay, so I open, and then what is moment? Force times moment arm, right? And then to calculate the moment arm, reference point is A here, right? And then what is the force? Resultant of this distributed load, right? So think about what is resultant from this distributed load. That's the force. And then moment arm is distance between the reference point and then point of action, right? And the where's point of action for the distributed load? I just talked about it, right? So I close after 20 seconds. Okay, so here C has the most votes, but we have quite a few A, B, and D. So let's calculate it together here. So the resultant, force, sum of all the forces acting on this beam, right? So that is kind of area under this load. So what is area? Height, W, base, L, right? So force is W times L. And then what is moment arm? L over 2, right? So from A to point of action. So this is the moment arm, and it's halfway, right? So L over 2. So L over 2. So final answer is WL square over 2. So C is correct. So I show you the, So 117 student, C is correct. And then D, one step further, right? Okay, so C is correct. Let's start our problem solving. Today we have 3 problems. First one is this problem 5.2. Locate the centroid of the plane area shown. So this area, right? So it's kind of very simple composite shape. So we can use these 2 centroid equations to calculate the centroid together. So how can we divide this area? Triangle and rectangle. Great. Yes. So I follow his opinion and then divide into this triangle and rectangle. Okay. So let's use this one as 1 and then this one as 2. And for homework and exam, you could have multiple or more than 3 subsections. So in that case, having a table is very convenient. So let's make a table. So like first one, header, and then second and third row for each subsection. And then the third one, the fourth row as a summation. Okay. So I'll give you the equation again. X bar is sigma X bar A over sigma A. Y bar is sigma Y bar A over sigma A. Okay. And then the left-hand side is what we need to calculate. And the right-hand side is kind of procedure to find final destination, right? So let's have first column as plus and minus. So the textbook doesn't use this one, but I recommend using this one. Textbook sometimes use minus area, but I don't think that makes sense. So, and then second row as section, and then we have two sections like this. And then the last one as sigma. And then we'll calculate area of each section. And then X bar and then Y bar of each section. And then multiplying these two each other. And then sum them up and calculate X bar and Y bar. So that is the procedure. Okay. So easy thing first. So area of each shape. I'm sorry, it's too easy. So area of the triangle, 1 over 2 BH. So B is 12, H is 15. So in minus it is 90. And then area of the second one is even easier. So BH, 21 times 15. So it's 315. And then I'm sure everyone knows it. Yep. So, and then about the first column, it is whether this you add this area to make the entire composite shape, right? In this case, we are adding these two. So each of them has plus sign. And then when you calculate the final area, then you can sum these two up, right? So then it is 405. Sometimes there could be bolt holes and then some other thing to cut out, right? Then those kind of cut out section could have minus sign, right? But for this, both of them are plus. And then next, X bar and Y bar. So X bar, Y bar, right? So the first part, triangle, where is the centroid? Triangle. So it's somewhere here, right? It was a clicker quiz, right? And then this is X bar 1, and then this is Y bar 1. Okay, and then what is X bar 1? It's triangle, and then this 12 inches. 4 or 8, right? 4, 8, 4, 8. This should be 1/3, right? So this is 4. Therefore, this is 12 minus 4, so this is 8, right? It's confusing, but this shorter side is 1/3, okay? And then now what is Y1? Shorter side. 5, yes. Okay, so we found X bar and Y bar. And then move on to the second shape here, rectangle. And then centroid, we know it's halfway, right? So I use different color. And then this is X bar 2, and then this is Y bar 2. Now what is Y bar 2? It's Y bar 2. 7.5. X bar 2. Need a little calculation. 22.5. Yep. That's right. And then how to calculate? So 12 plus half of 21, right? So 12 plus half, so it's 22.5. Great job. And then now the remaining part, I use larger portion, and then we can calculate x bar A and then y bar A. So multiplying this to 90 times 8, right? So that's 720. 90 times 5 is 550, something like that. So for second one, x bar times A, this times this, now you need a calculator, right? And then y bar A, this times this. I got these two numbers if you want to compare with your calculation. Okay, did you get these two numbers? Okay, then move on. Now we need to calculate these numerators here, numerator, sum them up using this. So now it's plus plus, so plus, plus, and then just sum them up, and you will have, I use my note too, 7,807.5, and then 2,812.5. And now the final step using this equation to find x bar. So x bar is this divided by this. And then y bar is this divided by this. So after calculation, you will get these numbers, 19.28 x bar, and then 6.94 y bar. And then once you have this one, don't stop here. Check it in the shape, right? So 19.28, this is 12, and then 22.5, so a little bit left side, right? So somewhere here. And the y bar is 6.94, so about 7. So less than y bar 2, right? Something like this. Somewhere here. What do you think? Make sense? Yes. It makes sense to me too. So then, yes, I can get this number, right? And then move on. Any questions? Yes.
Regarding the measurement of x bar for section 1.
Uh-huh. Sure thing. So the first shape, so I plotted here. So this is 12, and then this is 15. And the centroid is here, right? And then what we just calculated is this, x bar 1. And then what do you think? Should it be, so this is 4, right? 12 divided by 3, right? That's 4. And then this should be 8. So that's why we used 8.
So you're basing it on like looking, or is there like a set fraction? Like, for example, let's say half.
Is this 1/3, right? So I plot this again here. So if this is B, this is H, and then this centroid, and then this is B over 3, and then this is H over 3 that is from the table. Yep.
That would just be taking the parts that were not.
Right, so that's here. We don't count this one, but we count this distance. Any follow-up questions? Yes, if it is rectangle, it's simple, but triangle, it's tricky to choose 1/3 or 2/3. Yeah. Okay, then move on to the second problem. So determine the reactions at the beam support for the given loading. So now we have cantilever beam here. A is free and then B is fixed, right? And then the shape of the discrete loading is composite, right? So now we can use what we learned to find the centroid and then resultant using this problem. So first thing first, let's analyze this discrete load. So it's composite shape. So we need to divide by simpler shapes. How can we divide? Triangle, rectangle. Yes, triangle, rectangle, right? Okay. So triangle, rectangle. Something like this. Upper triangle and then lower, longer rectangle. Okay. So then, let's see. For the triangle, what is the resultant? Area under, let's start with rectangle. Okay. Let's start with the rectangle first. This one, okay? It's easier to calculate the area. Okay, what is the resultant area under area within the rectangle? B and H, right? So H is 40 pound per inch. And then B is 4 plus 6, 10. Right, and then focus on the units too. So inch, per inch and then inch. So cancel each other. Multiply by 40 and 10, 400. And then final resultant is 400 pounds for the rectangle. Any question about this? Okay, and then point of action. Where is the centroid? 5. Great. So 5 is the centroid, and at here, all 400 pound is acting. So that is equivalent loading approach. Even though this load is distributed, but when we set up moment equilibrium equation, we consider this load is 400 pound acting here. Okay. Okay, so our analysis for this rectangle is done. And now moving on to this triangle here. What is the resultant area under this triangle? 1 over 2 BH, right? So 1 over 2 with H. This is 90, and then this is 40. Use 90. No. We should use this one only, right? And then that's 90 minus 40, so 50. So 50 pound per foot. And then B, 6 inches. Oops, I used feet. Should be inch. And then these inches cancel each other, and we can calculate this number, and then it is 150, right? 150. And then now, where is the centroid of this triangle? we talked about this, right? Triangle, 1/3 B, 1/3 B, and the 1/3 H. And then moving on here, so we have this triangle. So 8, okay, 8 from left, 2 from B, right? So here it's 150 pound, and then this is 2 inches, and then this is 5 inches. Okay, so after this analysis, plotting this one is greatly helping. So it's part of the free body diagram here. So FBD. And now we simplified our distributed load, and to complete the free body diagram, we can add the reactions at the support. So A is free, no reactions. And then B is fixed. So how many reactions do we have? 3, right? So Bx and By, and then moment at B. I use all positive directions. Okay, and with this, we can set up moment equivalent equations. So the reference point, you can use any point, A or center or B, but I recommend using B to eliminate other unknown reactions. And then assuming one side as positive, and then let's count all the moments together. So your moment by By, By times 0. Okay, moment times Bx, Bx times 0. And then moment from MB, 0 or MB. MB is correct. It's not 0 because we cannot. So moment is moment itself. It has already force and distance. So we are not supposed to multiply another 0 distance to moment. So if you see moment, you either add or subtract in your moment equation based on the direction. And here we use the same direction as positive direction, so I added MB. Okay, and then now we have these two forces. So moment by 150 about B, 150 times 2, and then plus or minus. It is inducing this direction of moment. Is it plus or minus? Plus, okay. And then moment induced by 400. 400 times, this is 10, 5, 5. And the same direction, so plus. Right? Okay, so what is the moment? It's negative, so minus. This is 300, this is 2,000, so 2,300. And the unit, pound, inch. So it is pound times inch, right? Moment is force times distance. Okay. Any question about this equation? It's very important. So I use 2 stars here. Okay. Once we have this moment, then other things are what we already did. So solving force equivalent equation in x and y. So fx equation. If right side is positive, then what x forces? Bx only. So bx is 0. And Fy equation, if we use upward positive, right? Then we have downward 400, downwards 150, and By is unknown. So By is sum of these two, right? So now any questions? So this is very important problem. So maybe you can try solving. Yeah, any question? Yes.
Why is the moment about the negative?
Here?
Yeah.
From this equation, yeah, I think this should be if moment is minus 2,300 here, then this equation is satisfied. About the direction, right? So we assumed the moment as counterclockwise, right? But we got minus. So that means actual moment is clockwise. Okay, so I show you this one here. So MB is actually this direction, so this direction, and then this. Okay. So for that, I know what you mean. So here is the cantilever beam. This is fixed, and then this is open, okay? And then there is a load here, okay? Then this beam will deflect something like this, right? What is the moment direction induced by the force? This direction, right? And then it is counterclockwise direction. Right? If there is only counterclockwise direction, is this structure equilibrium or not? No. We need something to counteract with this loading. And that is the reaction and this support. And if we have counterclockwise moment 2,300 here, what do we need to make this equilibrium, in equilibrium? The same amount of moment, the opposite direction, like this, right? And then that is what we just calculated. So 2,300 pound-inch clockwise. And then we have this kind of movement, right? It's from the force and it's from the reaction. Then this structure is in equilibrium. So did I answer your question?
Yeah,
No?
we realize it's the reaction.
That's why it's because this is reaction, the direction should be this one. And then you thought about this, right? So good question. Any other questions? Okay, then moving on to the last one, integration. Sorry about the blurry printing. And then here, determine by direct integration the centroid of the area shown. Express your answer in terms of A and B. So A is this distance, and then B is this distance, and then the function here is a quadratic function about x, right? So y equals k times x minus a squared, and then we see k, right? And then it's bothering, right? Because we need to express everything in terms of A and B, right? So we need to eliminate k. So first step is eliminating k. So how can we do that? We can use some of the points, some of the known points, and then substitute in this equation to find out the expression between k and A and B, right? So we can use either 0 comma b or a comma 0 to this function. Which one would you choose? A comma 0, then 0 equals to 0. And then it's kind of trivial. So you can try, but it will not give us good information. So check, but it's not good. And then another choice is 0, comma b. Then y is b. And then k. And x is 0. Right. And then we can find k equals b over a squared. So we found that expression, and we can eliminate k by writing this equation as y equals to b over a squared x minus a squared. So that is the relationship between x and y. Typically, a and b are constant, right? And now, to find the centroid, let me give you the equation here. So x bar is integral x bar L dA over integral dA. You already have it in the slide, so you can write in the end. You don't have to write right now. Y bar L dA over integral dA. So these two are the centroid equations for the continuous shape. And then now we need to conduct the integration 3 times for this, and then this, and this. So for this problem, I use think pair share or group problem solving for the integration part. But before that, I'll explain the procedure. Okay, then I'm reviewing to find this dA. So what is dA? We find some representative strip here, right? And then this point is an arbitrary point with x and y. These two are variables, right? And then this strip width is dx because we are cutting vertically like this, right? And then what is the height? If the coordinate of this point is x comma y, the height should be y, right? And then now we can define dA. dA is area of this strip. So it's rectangle. If it's rectangle, then base times height. So y times dx. Right? And then now we have this y function, so we can substitute this one here to conduct the first integration, right? Okay, before moving on, let's find out x bar L and the y bar L too. So x bar L, y bar L is the coordinate of this small strip, okay? And then it's somewhere here, midpoint, right? And then this is x bar L, and then this is y bar L. And let's start with y bar L. So y bar L. What is y bar L? Entire height is y, and centroid is halfway. Yes, this is y over 2. Then x bar L is a little bit tricky. What do you think? What's x bar L? From y-axis to the centroid. Here. dA, dx. dx is this one. So it is much shorter than x bar L. And please use this coordinate. So this coordinate here is x comma y. X minus d, x. So yeah, x, if this is x, x minus dx is somewhere here. Very close. If this is x, so its left side is x. Instead of right side, yeah. A minus x. So here, a minus x. So there's this distance. It's kind of inverse approach. So this distance So it's not exactly x plus dx over 2, right? Because x is this point, and then dx is this base, and then centroid is center point, right? So I write it down, x plus dx over 2. So strictly speaking, this is x bar L, but because we will integrate this times this, so it will induce dx squared if we consider this, right? So we will ignore this portion and just use x for x bar L. It's very small. Yeah. Okay. But I hope you could have some opportunity to think about what exactly x bar L is. Okay, any questions? Yes.
Why did you zero out the dx? Is that included in dx?
Great question. So let's see. If I may exaggerate the strip here. So this is x, this is y, and this is the strip. And then this point is x comma y, and then this is dx. And then centroid is here, and this is x bar L. Do you see clearer here? So x bar L is x plus dx over 2. Okay. Okay, then move on to the integration. So first area is integral dA, right? And dA is this. So I write y times dx. And then y is here. So b over a squared, x minus a squared, and then dx. Great. So this function is in terms of x, and a, b are constant, right? And then what is the interval? Integration interval. About x. So non-zero x between 0 and a. Okay, so that is first integration you will solve. And the second one, x bar L dA. So x bar L is just x. We'll use x. And then dA is y dx. Right? So I may substitute this one here. So this one x minus a squared, but I just distribute and then write like this. So I went one step further, so write down here. So this is the same as this, right? This. And then you can multiply each one and then integrate. Right. Any question about the second one? Okay, and the third one, y bar L times dA. Y bar L is y over 2, right? And then dA is y dx. So 1 over 2 y squared dx. Right, so y at this one, and then this 1 over 2, 2y and dx. And then I may use this y equation, so y squared, so b squared over a to the fourth, and then this to the fourth, right? Okay, so to solve this, I give you about 2-3 minutes. So it's form 2 or 3 students, and then you will have individual time, so 2 minutes to solve this one, and then compare each other, and then let's check it afterwards. Okay, so if you had individual time, check your calculation with your peers. Any group who can share what A is? If you see multiple numbers or answers, then it is very high possibility to be right, to correct, to be correct. No? Okay, then let's check it together. So first one here, b over a, and then integrating this one, so 1 over 3, x minus a to the third, and then from 0 to a. And then I saw a lot of students stopped here or here. Yeah, it's a long time ago, but please review the integration part. Right, then coefficient in front, so b over 3a squared, right? And then if we input a here, what is the result? A minus a, 0. And then if we input 0 here, what is the result? Minus a cubed. Minus a cubed. Right? And the final answer is minus minus plus, right? So 1/3 AB. So if you, so how many of you got this here? 1? Okay. Okay. Yep, then move on to the second one. Here, we need intermediate calculation here. So I use integral from 0 to a and then b over a square and then multiplying by this 2 x cubed, this 2a x square, and then this 2a square x dx. And then we have this coefficient in front, and then calculate the integration of each term. So 1 over 4 x to the fourth minus 2a, and then integral x squared, 1 over 3 x cubed, and then a squared, and then this one, 1 over 2 x squared from 0 to a. And it's much simpler because if x is 0, everything is 0. So if we input a to the fourth, a to the fourth, a to the fourth, so it becomes to a square b times 1 over 4 minus 2 over 3 plus 1 over 2. And then when you calculate this coefficient, it is 1 of 12. So the second integration is 1 over 12 a squared b. Anyone who got this number? No one? Oh, okay, 1 there, 2. Okay, good, thanks. Very good. Yeah. And then the last one, you check the answer. So here, 1b squared over 2a to the fourth, and then integration of this, 1 over 5x minus a to the fifth. And then I saw some of you got this up to this point. Great. And then now coefficient, so b squared over 10a to the fourth. And then if we plug in a, it's 0. Plugging in 0, it's minus a to the fifth. So minus minus plus, right? And the final answer is 1 over 10 a b squared, right? So this is this, right? And then is that all? No, we need to find the centroid, right? Centroid is this over this and then this over this, right? And then here, this is symbolic, so it's tricky. So the method, the way I use is just calculate 1 over a and then multiply. And then what's 1 over a? It's 3 over AB. And let's multiply this to this and then this. Okay? So x bar 1 over 12 a squared b times 1 over a, so it's 3 over AB. Right? And then b gone, and then a, right? 1a gone. So 3, 12, 4, right? So 1 over 4a. And then y bar, this times this, right? So 1 over 10, ab squared times 3 over ab. So now 3 over 10. And then a gone, 1b gone, so it's b. Okay, so that's the centroid of this shape, right? And then the equation was this too, and then please review. Please review two equations, the integration, how to conduct the integration.